Hey there, this is our introductory video to right triangle trigonometry. Okay, so let's talk about a couple of things. Number one, you have to have a right angle or this doesn't work. Okay, so if you have a triangle that doesn't have a box in the corner, do not assume it is a right triangle. Do not assume these things work. Number two, we have to have an angle, right? We're talking about the trig ratio of an angle. This is called your reference angle. The angle that we are referring to, in other words. And this symbol, right, this is a Greek letter. It is a lowercase letter of theta. It represents the Greek th sound, right? Theta, the th sound in English is represented by a single symbol in Greek. So this is theta. This is our variable for trigonometry, our variable for angles. Okay, so it's a circle with a squiggly line through it. That is not a zero, that is a Greek letter theta. Okay, and it's the reference angle that we base our three different sides of our triangle upon. Actually, one of them is always the same, right? What's the longest side of a right triangle called? The hypotenuse. Okay, the longest side is the hypotenuse. It can be always found because it is across from the 90-degree angle. The hypotenuse is the side across from the 90-degree angle. Okay, that's always the hypotenuse. That side never changes depending on your angle. Now, the other two sides will change depending on your angle. So the side down here that makes up your angle, right, the hypotenuse, and this side is called your adjacent side, or ADJ for short. Okay, so that's the adjacent side. The adjacent side and the hypotenuse make up your reference angle. And then the side that doesn't make up your reference angle, the side that is across from your reference angle, this is called your opposite side. So we have three sides to a right triangle. Depending on where the angle is, you have the opposite side, the adjacent side, and the hypotenuse. Okay, so being able to identify the sides of your right triangle is the start of getting our trig ratios correct. Okay, because these are all ratios. A ratio is simply a comparison of two things. Okay, so we're going to compare two specific sides of our triangle for each of these three trig ratios, right? Sine, cosine, and tangent. So yes, even though the letters are S-I-N, this is not church. This word right here is sine. Okay, that is S-I-N. In math, we call that the sine, right? This is not church. It is a sin to call that sin when it's actually sine. Okay, sine of theta. So the sine is a ratio or a comparison of two specific sides of your triangle. And those are which two sides? Do you remember from geometry? No, good. The opposite side compared to the hypotenuse. Sine is opposite over hypotenuse. Okay, the sine of an angle is the ratio of the opposite side length to the hypotenuse length. The cosine is a ratio or a comparison of the adjacent side length to the hypotenuse side length. So the cosine is the adjacent over the hypotenuse. And our last trig ratio from geometry, the tangent, is a comparison of opposite side over the adjacent side. Okay, you should commit these ratios to memory because we will use them over and over and over. So now let's talk about our other three trig ratios. Okay, so we have three of them, the cosecant, the secant, and the cotangent. And these, like it says, are all reciprocals. The cosine is the reciprocal, the cosecant is the reciprocal of the sine. So if the sine was opposite over hypotenuse, that means the cosecant is the hypotenuse over the opposite. Okay, it's the reciprocal ratio of the sine. So we flip the fraction. The secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. right? It's a ratio, so we're writing down side lengths. And then our last one, the cotangent, is the reciprocal of the tangent. Tan is opposite over adjacent, so cotan is adjacent over opposite, okay? So the letters don't go together, right? Sine starts with S, its reciprocal starts with C. The S and the C go together. Okay, sine goes with cosecant. Same thing for cosine and secant, right? The S and the C go together. The C does not go with the C. The S does not go with the S. Sine's reciprocal is cosecant. Cosine's reciprocal is secant. So let's practice some writing trig functions with two examples. What side of our, actually first we need to have a reference angle. I'm sorry, I didn't update this. Let's call this one the reference angle. Okay, it doesn't have to be the bottom one, but most of the time it is. So if that's our reference angle, what side of our triangle are we missing? The hypotenuse. So our first thing we have to do is calculate the hypotenuse. And whose theorem are we going to use to calculate the hypotenuse? Pythagoras' theorem. We're going to use the Pythagorean theorem, which says if I take 5 and I square it and add it to 12, because those are the legs of my triangle or the sides of my triangle, that needs to equal to the hypotenuse squared, right? The sum of the legs, the sum of the squares of the legs is equal to the hypotenuse. So you might need to get a calculator to do this, unless you've memorized all of your squares. So our first thing is to get our side of 13. So let's identify. 13 is clearly your hypotenuse. What side of our triangle is 5? 5 is the adjacent side, right? Because it's the side that makes up your angle. The hypotenuse and the adjacent make up your angle, which means 12 is your opposite side. So we have our adjacent side, our opposite side, and our hypotenuse side. So let's write down your 6 trig ratios. So sine is a ratio of your opposite and your hypotenuse. So the opposite side is 12 and the hypotenuse is 13. So the sine of that angle is 12 over 13. Okay, the cosine, the adjacent side is 5. The hypotenuse is 13. So the cosine is 5 over 13, right? It's just a ratio. It's a comparison of two sides. And the tangent is the opposite side 12 over the adjacent side 5. So the tangent is 12 over 5. Okay, ratios of opposites and adjacents and hypotenuses. So now let's do the other 3 by just simply reciprocating. Cosecant is the reciprocal of the sine, which means the cosecant is 13 over 12. The secant is the reciprocal of the cosine, so the secant is 13 over 5. And tangent is the reciprocal of the, cotan is the reciprocal of the tan, so cotan is 5 over 12. Okay, so we're just writing down the ratios, which is a comparison of the 2 specific sides for each of your 6 trig functions. Okay, example number 2, I think is going to be a little bit trickier because 7 and 10 are not Pythagorean triples. But let's do the Pythagorean theorem to find our missing side. Oh, we need an angle for this one too. Let's put it here. Let's make that your reference angle. Sorry it wasn't on there before. So for this reference angle, 7 is the opposite side because it's across from the angle. 10 is your hypotenuse. So we are missing our adjacent side. So let's use the Pythagorean theorem to calculate that missing side first. So we have radical 51, or the square root of 51, as the side length for the adjacent side. So now that we have all of our 3 sides, we can write down all 6 of our ratios. Okay, so our ratios, we have opposite side of 7, hypotenuse of 10. We have adjacent side of root 51, hypotenuse of 10. And tan, we have opposite side of 7, hypotenuse of root 51. Now, there was a time in my life where that was not okay. Nobody wanted to leave a radical in the denominator. So if that is your teacher, we'll talk about how to get rid of that here momentarily. Okay, and it is called a place called rationalizing the denominator. Okay, rationalize, because a square root is an irrational number, right? The square root is an irrational number. It is a non-repeating decimal, so it does not fall into the same category as our numbers. An irrational number. So in order to take our irrational number, we're going to rationalize it, right? Makes sense that that's what we would call it. If it's irrational, we want to make it into a rational. And we do that by multiplying by itself. So if we were going to simplify the tangent, we would multiply the top and the bottom by root 51 over root 51. And of course, this is our fancy 1, right? Anything divided by itself is just 1. And we can multiply by 1. That's the multiplicative identity. Multiplying by 1 doesn't change anything. So we multiply by this fancy 1 because you want to get rid of root 51 on the denominator. So what is root 51 times root 51? Well, that's just normal 51. Anytime you multiply a radical by itself, the radical part, the square root part, goes away. Now the top is 7 roots of 51 over 51. So you might see your answer represented like this in a multiple choice type question for the ratio of your tangent. Okay, same thing with the secant over here. You might see it as 10 roots of 51 over 51 by that same notion. You would multiply both top and bottom by root 51. Okay, it's a pretty simple, right, hack to flip-flop switch. But the math behind it is you want to make the denominator no longer an irrational number. You want to make it into a rational number by multiplying it by itself. Okay, so you might see that in the future, or if you're asked to do it, that is how you do it. Okay, so let's flip to the back and look at the rest of these notes. So here's our point. We have the point 6, 8. We want to make a right triangle and write down our ratios from this. Okay, so 6, 8, that's 6 units to the right and 8 units up. We'll make that point right here. This is the point 6, 8. 6 units right and 8 units up. Okay, so we're going to make a triangle, and this is how we make our triangle. Okay, we're going to draw from that point back to the origin. We're going to draw from that point down to the x-axis, and then we're going to follow the x-axis back to the origin. Okay, we're going to make right triangles. That is our goal, because if we have a right triangle, we can figure out lots of stuff. So there's your right angle. Remember, every vertical and horizontal line are perpendicular. So that's where we get your right angle from. So we know that we went 6 units in the x direction and we went 8 units in the y direction, right? So the x direction is your horizontal distance. So 6 is your horizontal leg of your triangle. 8 is your y value, which is your vertical distance traveled. So we know that the vertical side of your triangle is 8. Okay, and then this is going to be your reference angle. The reference angle is formed at the origin. Okay, all of our triangles that we draw are basically going to be oriented like this. Their orientation will be with the x-axis as one of their side lengths, and only the x-axis. Okay, the angle is formed at the origin. Now, first thing we have to do is use Pythagoras to find the hypotenuse. So 6 squared plus 8 squared equals 10 squared, right? This is one of our Pythagorean triples. It's a 3, 4, 5 triangle. Well, 2 times 3, 2 times 4, 2 times 5, so 6, 8, 10. 6 squared is 36, 64, 36 and 64 is 100. Okay? So now we have one extra step before we can find your trig ratios, and that's to draw your triangle and find your hypotenuse. And after that, it's back to your ratio game, finding out all 6 of your ratios. So let's do that right now. Okay, so there's your 6 trig ratios, and now let's write down all of their comparisons. Opposite over hypotenuse and all those other wonderful whatnots. So one thing to do is, if we can simplify your ratio, the sign is the opposite side, 8 over the hypotenuse 10. 8 over 10 have a multiplier of 2 in common, so we can reduce that ratio to 4/5. Okay, so when we can reduce the ratio, please do reduce the ratio. Every time we have a common multiplier, reduce. And then we can simplify, right? Your cosecant is the reciprocal of the sine. So if the sine is 4/5, the cosecant is 5/4, and so on and so forth. Okay, so hopefully this is a pretty solid basic thing for our trig ratios, using Pythagoras to find the hypotenuse, and then using our trig ratios to write the fractions. So let's do example 3 together because it has some radicals in it. Right? These are kind of unfamiliar maybe. So let's increase our familiarity. Root 19. That is your x direction. Right? So your bottom side length is root 19. Root 15 is your y direction, which is less than 19, by the way. So our line should be not as long as whatever you made your x line to be. Right? Root 19 is bigger than root 15. So the bottom side should be a longer line than your vertical side. And then we have to draw your line back to the origin in order to calculate the hypotenuse. Okay, so let's do some of this silly stuff. Root 19 squared plus root 15 squared equals hypotenuse squared. So here's the fun part. Root 19 squared is just regular old 19. And root 15 squared is just regular old 15, because squaring and square rooting undo each other. 15, no, that's not 36, is it? Whoops, that's 34. Boo. Thought it was fun. So root 34 is going to be your hypotenuse. 15 plus 19 is 34. I'll change that to make it a 17. Okay, so we have our 6 trig ratios, and they're all going to have radicals in them, which may or may not be fun for the lot of you. So those are your first 3 ratios. Now, if we were going to be really mathematically correct, we would multiply the bottom and the top by root 34 to no longer have a radical in the denominator. 15 times 34, well, I'm going to need a calculator for that, so hang on. Root 510 over 34. And I don't think 510 is reducible, not divisible by 4, not divisible by 9. Yep, so that's pretty much it. Root 510 over 34. Okay, so if you want to be crazy and it asks you, if it asks you to reduce, I'd just be able to do it for a multiple choice question on a test. So those are all your ratios. Right, so we have 6 of them: sine, cosine, tangent, and then the reciprocals, cosecant, secant, and cotangent. Okay, so commit those ratios to memory. We will use them a whole lot this year. Okay, goodbye.